Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 12G assignment. Okay, first one we're going to take a look at here is number 1. Data set has lower quartile 31.5, median 37, upper quartile 43.5. Calculate the interquartile range for this set. Okay, so that's interquartile range. We've got the upper quartile is 43.5, lower quartile is 31.5. So that gives us a range of 12. Okay. Calculate the boundaries that identify outliers. That's going to be our 31.5 to 43.5, right? We're going to use those numbers to calculate the actual boundaries that identify the outliers, right? So we take our 12, right? If you remember, we take 12 and always multiply it by 1.5, and that's going to give us 18. So our lower boundary would be 31.5 minus 18, and the upper is going to be 43.5 plus 18, right? So that's going to give us, let's see, 0.5 and what, 13.5 is the lower, and then the upper boundary is going to be 4, 5, 61.5, so 13.5 to 61.5. So those are our boundaries. For C, smallest values of the data set are 13 and 20, and the largest are 52 and 55. Which of these are outliers? So anything that's less than 13 and a half, which is B13, so 13 is an outlier. And anything that's more than 61.5. So the only one that's an outlier is just 13 for part C, right? Okay, that looks like a B, but it's really a 13, right? Let's fix that a little bit so we can, there, that looks a little better. Okay, and then B, draw a box plot of the data set. Okay, so we can literally have, let's see, our lower quartile is 31.5. The median is 37. That's pretty close together. That's only off by, what, like 5.5. And then the upper quartile is 43.5. That's only like 6.5, so that's not too far up there. So here's our box. And then our, let's see, our whisker. We don't really know exactly. Oh, I guess we do know the smallest and the greatest. So we've got, let's see, this is 43.5. And then this whisker here goes up to 55. And then this whisker goes down to 13. So there would be our box plot. Although 13 is officially an outlier. So since that is true, we'd want to actually change this. 13, we want that to go down to 20. And then we're going to have 13 even farther down, right? And it's usually best to draw this on a scale here. We're just doing a quick sketch, so not any big deal on that. Okay? Okay. Let's take a look at the next one. Number 3, match each graph with its box plot. Okay? So, let's see all of these. Well, let's see. I mean, you can really kind of like pick and choose here, but we've got a bunch of data that's all squished down here at the bottom on, say, B. Okay, so that means that this is going to have a tight little window down here at the bottom. So this is looking like D. Yep, and let's see, there's 13. There's our outlier, and 9's another outlier. So B, this is definitely going to go with graph D right here. That graph is going to go with this one here. This one, you can see our data is a little bit skewed a little bit more to the right here, and then it really kind of drops off at 7 and 8. Okay, so let's see. Could be this one right in here, right? Okay, just taking a quick glance at C here. Look, we've got this one here, 13 and 1. If you look on this graph C, here's 1. Here's 13. The next one is at 10. And the lowest one there is 4. So this one here is definitely C. So we've gotten a couple of them taken care of here. And then, look, these are pretty close to the same, aren't they? Only thing with this is that the data is a little bit farther spread out between the 3 and the 6, where the data is pretty tightly packed in between the 4 and the 6 there for these. So let's see, 4, 5, and 6. 4, 5, and 6, that's kind of the tighter packed data here, so I'm thinking that's probably going to go here. 8 is the highest, 2 is the lowest, and then over here 1 is the lowest and 8 is the highest. So D definitely goes to B, and then A goes with A. Okay, so we got A, D, C, and B for those. Okay. Last one to take a look at is number 7 here. Consider the data set. Find the standard deviation for the data, upper and lower quartiles, outliers, and then a box plot. So you certainly can stick this into the graphing calculator or the scientific calculator for that matter, and figure out what the standard deviation, upper and lower quartiles, let's see, we'd still have to hand calculate the outliers, and then we'd have to obviously hand draw the box plot. But you can use your calculator to come up with this stuff if you so choose. Or again, there's not a lot of data. What is it? 1, 2, 3, 4, 5, 6, 7, 8. There's only 9 pieces of data, so you could do it by hand as well. I'm going to use the calculator. Okay, so I went through and put all the data into the scientific calculator. You can basically do the same thing with the graphing calculator. And then on scientific calculator, we're going to do second data, which is stats. It's going to give us the statistics for this. One variable statistics is what we want because there's only one variable here. So the data is in list 1. Our frequency, all these just have a frequency of 1. We can later on we'll do the stuff with where there's we'll use list 2 for the frequency, but anyway, for us right now, frequency is list 1, and then it gives us all of our gives us all of our data. I gotta go back, sorry, pushed too many buttons. There we go. So X bar is our mean. Okay, so we want, let's see, we're going to have to draw a box plot anyway, so I'm just going to go straight to D here. And we know that our median is 121.2. Let's see, we know this is going to go from what, 93 up to 135. So let's do this. Let's do, say, 90. We'll draw ourselves a little scale here up to 135. So we got 90. 100, 10, 20, 30, 40. Okay, and then we can maybe get rid of the rest of this. All right, so there's our 100, 110, 120, 130, 140. Okay, so now we can put all of our pieces of our box plot in there. So 121 is our median. So we'll go right here. And I even like to write what our median is. Okay, so we've got that. Well, let's see. Let's find our other important stuff here. There's our little sigma, which stands for standard deviation, so 11.65. So we're going to call that 11.7 is our standard deviation. Okay. And then upper and lower quartiles, we can go down through here. Minimum, let's do this. Minimum's 93. And interesting, they've got the median as 122. Yeah, because, sorry, 121.2 was our average, so that's not really our median, is it? Sorry about that. Okay, so we've got minimum we know is 93. That makes sense. 93, quartile 1 is 117 and 122. So we got 117, 122, 93, right? Sorry for the squiggly lines. Let's see, and then if we keep trucking on here, we got 130 and 135. So 130 is the end of the quartile, and 135 is the end of the whisker, right? So basically our box and whisker plot Looks like that. This is 130 and this is 135. So we did D. Upper and lower quartiles of the data set are going to be 117 and 130. And then are there any outliers? It looks like we're good over here, but 93 is a pretty good chance of being an outlier, right? So I'm going to take 117 to 130. So 130 minus 117 gives us 13. We got to take 13 times 1.5. 13 times 1.5. And that gives us 19.5. So we take 117 minus 19.5 minus our answer. We can just do second answer, go a little quicker. 97.5 is the end of that. So here's our cutoff. So really 93 is an outlier, isn't it? So then what we got to do is then go back to our next smallest piece of data, which is what, 116. So then we go to 116, which is right about here. And then we're going to erase all this stuff in between because that 93 there is an outlier, right? If we take 130 and we add 19 and a half, that definitely goes past 135. So that one there is, or 135 is definitely not an outlier. So we would say yes, and that is 93 is our outlier. And then we drew our box plot. Okay? All right, that's all we have for the problems for the 12G assignment. If you have any further questions on any of these, please feel free to ask. Thanks.